very much, Nico, for the introduction and also for being such a wonderful host. So, and thank you for being here at such a quite a late hour and such temperatures today. I try my very best to entertain you. Although I realized when I was preparing the talk that I will talk quite a lot about, I called it challenges, but I will point to quite a few problems, but also possibilities when you use a comparative approach to understand humans. These are the aspects I would like to address. What is a comparative approach? And I'm sorry, I know some of you, we have discussed this extensively over the last weeks when preparing the follow-up proposals for your cluster. I would like to very briefly point to some topics in comparative research, and then, as I said, point to methodological and ethical challenges. And Nico also asked if it's possible to specifically talk about the issue of anthropomorphizing other species. Okay. What are primates? As a biologist, it's not so easy to characterize primates as a group. So to find features that are unique, characterizing just for these very many different species. The number ranges, so we just discussed this, with genetics, the number of species has drastically increased. But I'd say on average, it is about 250. Very importantly, humans are primates, represented by only one species today. With the exception of humans, non-human primates are limited to tropical areas, subtropical areas. They realized very different social systems, feeding ecologies, and so on. And the one characterizing feature, in addition to the importance of vision as sense, and also we have mostly nails, not claws, is this one characterizing feature that we are highly social throughout our lives. Of course, many species are, but for primates it's very typical. It's not limited to certain times of the year, for example. So first course on what primates are, very important also, you are not only a primate, you're also a great ape. Because the biological, I will say something about the distance between the different species in a second. But since we are so closely related, biologists would differentiate between human great apes and non-human great apes, for example, but to not get a knot in my throat because it's very difficult to pronounce, I will stick to humans and great apes for this talk. Okay, so what makes us human? If you would have asked this question about 50 years ago, the answer would have been tool-used. Humans are the only species that use and manufacture tools. Then Jane Goodall came as one of the still leading figures in the field. I think she just turned 90 and is still giving more than 300 talks every year. And she found that chimpanzees use sticks, for example, to fish ants and termites. And not only this, they even show different behaviors depending on which species they forage on. They use stones to crack nuts. And a more recent discovery is that they even do some fishing, so they use rods to fish algae from a pond. So then it was clear, okay, no, this is not a characterizing feature of what makes us human. Then we found tool use in orangutans, so another species of great apes, nut cracking in a monkey species. So in German we usually don't say, so in English we have apes and monkeys, in German we just say Affe. If you want to be 100% correct, say Menschen Affe and Tieraffe. This is not a scientific term. Then, Alex Gachanek is also part of the cluster. He had this amazing example that both manufacture tools, and then even non-vertebrates have been found to use, in this case, shells to build a safe house for them. And so the very famous quote that was the result of these discoveries is by Louis Leakey, who was Jane Goodall's mentor. Now we must redefine men or accept chimpanzees as humans. Okay, and in psychology now, we try to identify the features that are unique to the human species. And so this is basically just I'm not sure, please interrupt me when you are familiar with all of this, but just that you know, these are the closest relatives of humans, so bonobos and chimpanzees, and more distantly related are several gorilla species. We have now 3 species of orangutans, and then we talked about this morning the very amazing gibbons, who are usually forgotten in comparative psychology, but I want to mention them anyway. And what you do is then you take a certain skill and then you test closely related species and see if you find this skill, for example, not only in humans, but also in other great apes. And then you can say with not 100% certainty, but at least a very high probability that most likely the last common shared ancestor of these 3 species, extant species, already possessed this skill because it is found in these different species. Okay, but it did not evolve earlier. So what you try is you try to reconstruct evolutionary history by looking at today's recent species and what they do in regard to their cognition. Then you might find a skill that's only present in humans. Then the question is this a feature that's characterizing humans? And the answer is, not really. We are not there yet. Because if you really want to answer this question, what makes us human, you have to show that it's not just limited to humans from Western societies, but basically that you can find this skill across the globe. And there are tons of problems related to this. But for today's talk, I will focus on the cross-species approach. Maybe if you have questions about cross-cultural research, then I'm happy to answer it also later on. And this is just what I've said and summarized it. So basically, it has been coined cognitive statistics. And the idea, as I just said, is if you find a trait in closely related species, you can say, yes, it was already common in the last shared common ancestor, but not in the common ancestor of this group because it's limited to these 2 species only. So this is the general approach. And in Germany, and who of you is a psychologist by training? I know, Leah, I know you know the story because you had to suffer in my course when I said, yeah, the problems, why should we, I mean, if you don't care about other animals at all, why should we study other species? And the point I would like to make is if you want to understand humans and human intelligence and this context here, you can imagine this to be a human. You can describe the apple in every little detail. You can gather as much knowledge as you want. You can study the apple for years. You won't know what is special about the apple until you have a frame of reference you compare it with. So you won't know that the shape of the apple is unique when you compare it, for example, to pears, right? I mean, I know this is a very blunt example, but just to demonstrate, we won't know what's unique about humans if we don't compare humans to other species. And that's why I think it's really important when we want to study human intelligence to also look at other species and not just great apes. Okay, there was a really famous study, already some time ago by Esther Hermann at the Max Planck Institute in Leipzig. And what she did was she applied a test battery to humans, 3.5 years old, chimpanzees, most of them adults, and orangutans also. And she had a range of different tasks. I will show them in a second. And when she summarized the tasks distributed in a physical domain, so basically the skills of apes when they interact with their non-living environment, and then to the social domain, so when they had to interact with either conspecifics or humans in a social setting. And the take-home message is basically at the age of, so when the humans are 3.5 years old, there are basically more or less no differences in their performance in the physical domain, but humans, you find significant differences when you look at their skills in the social domain. And so these are the 2 different, again, physical cognition and social cognition, and then you have these different tests on space, quantities, causality, and you see here social learning, communication, and theory of mind, and here you could find the differences. Again, to be honest, I could fill a whole talk with like a discussion about problems related to the study. Again, we can do this in the discussion, but I will come back to this study later in my talk. Maybe you can keep this in mind. Okay, so I promised you some hot topics. So I don't know if you have followed the news in the last, I think it was just 2 weeks ago. Oh no, it was not a humor study, it was but the same author. A self-medication, I'm not sure if you have heard about orangutans who treated his wounds. To be honest, this was known for chimpanzees already for quite some time, but we come back to the issue of fancy findings in comparative psychology and the attention you can raise with them depending on the species you study with. It's again co-finding, but it was known already, but published in a different journal. Then humor is a big thing. So can apes tease? Maybe you also know this YouTube clip from the little orangutan with a trick where the visitor in the zoo shows them the cup, and then suddenly the cup is empty and the orangutan flips and seems to really enjoy himself or herself. And it has been used as an example to show that they have humor. So this is a huge research topic at the moment. Then cooperation and prosociality, because humans are considered to be a hyper-cooperative species, so we cooperate in situations and to an extent which would not be necessary for our survival. And the question is why? Personality is a big thing at the moment. Are there systematic differences between different individuals, and how does this impact their cognition? I will talk about theory of mind a little bit today, and the effort, we call this as a whole publication on the effort. We were not allowed to talk about friendship until about 5 years ago, because many of the relationships between apes you can explain by rank relationships or kinship. But then there are some of these individuals spend more time together or support each other more or groom each other more than you would expect or would predict based on their relationship. And now there's a big Jan Engelman, who's now at Berkeley, this is his big thing. So yes, if you have any questions afterwards, I'm happy to talk about some of these studies. Okay, but I wanted to talk about some challenges in the fields. And first I would like to focus on the methods. So the problem is, how can we measure something that we can hardly observe? So we talked about this morning, right? Mental processes are basically happening in a black box. And how can we study such processes in a very closely related species? So maybe we wouldn't care so much if we look at a snail, but we care very much about chimpanzees. And I'm also happy to discuss this if this is okay. And it's a very highly endangered, so all of the great ape species are highly endangered. And how can we study this in a non-invasive way? So what are the possibilities and what are also the limitations? One method that got really quite popular over the last couple of years, in particular by Fumihiro Kano, who's now in Constance, he really does amazing stuff. He trained a whole generations of researchers to use this method. And eye tracking is used, for example, for face and emotion processing. Just to show you that apes are much less likely to focus on eyes and mouth region. So what they do is they have a much faster way of processing faces and also pictures in general. And unlike humans, which might be not very surprising, they do not focus so much on the eyes, because in many primate species, non-human primate species, a direct glancing at someone directly is a threat. So like, for example, in baboons. So don't stare at a baboon, and maybe also not a gorilla, male in particular. It's also used to study social attention. So when you present them pictures or videos, where do they look? We really have very little understanding still when we interact with them, when we have a test situation where we present them a certain problem and then have to solve it, which cues they use from the human experimenter or from another conspecific to basically then start their own, behave accordingly. We don't know where they pay attention to, or very little. And again, I will talk about theory of mind and false belief understanding, and about 8 years ago, Christopher Peña managed to use eye tracking to show some evidence for false belief understanding also in non-human great apes. Okay, so this is what you can do. What are the problems? I know here you are aware of the different systems. Many of the technical solutions that exist are not suitable for non-human great apes. So we cannot, so this, don't put any equipment into an ape enclosure, and you know how much it costs. You will not get, you get it back, but in pieces. They will trade it back, but they first will break it into pieces and then trade it back for food. And we don't want this one because it costs a lot of money. Of course, any invasive stuff is out of question. This is not allowed. We cannot do such things with great apes. Toby had developed some goggles some years ago, and it was used in a Kyoto Primate Research Center, but they train their chimps in a very specific way, so they go inside. This is something, this is a completely different way of interacting with the individuals, not so common in Western societies. So, and again, this is amazing that she does it. I would not try it with the Leipzig chimps because they eat it. So, yeah, it's not safe to put anything inside. And what we did is, I'm not sure if you can see, so we used it. Are you using a Toby eye tracker here as well? Sorry, yeah?
Not much.
Not much, yeah. The nice, I mean, this is really the, because we also use it in sanctuaries, I will show an example in a second. It's nice because you basically, you need a screen, and then you just clip it onto the screen, and then it's basically using infrared to measure the reflection of, basically on the reflections, measuring where the apes are looking at, and I show you an example in a second. And this is the system that we're using. So this is also something we cannot do. Again, this is from Japan, but there's no way, we are never allowed to touch the apes or to be inside the same room with the chimpanzee. And the problem is, of course, they move their heads all the time. They have a very short attention span. So when we do eye tracking studies, we usually present the stimuli for 1 second. And the whole test session usually lasts 1 minute. And then the next test session takes place another day. Pupil dilation is also really tricky because of it's difficult to control the light conditions in the settings we are working in. So I hope I show you a little video to see how this is working. The question is, how do you manage so that apes don't move? This is a plexiglass panel, and this is actually the method Kano used. And this is not medication. It's fruit juice, which they really like, which we have to dilute with a lot of water. Otherwise, we get a weight problem. Not we get a weight problem, but the apes, they gain too much weight because they can drink a lot during such a session. And then there is a hose and a little pipe. And basically what they do is they drink while they're looking at the screen. So the eye tracker is attached to the screen, and this is just a control monitor, so the experiment has not started yet, but we can then see if they are actually where they are looking and if they're still paying attention, because they might sit there with their eyes downwards and not look at the screen. Okay, problem is we also work, I never worked in the real wild in the sense of in the forest, and there you can't do these kind of studies for different reasons, but we work in sanctuaries, for example in Zambia and Chimfunchi. And so we had back then no electricity, so we first had to buy a solar system. We had to build a shed, because the problem is of course changing light conditions. Very unexperienced chimpanzees, so they are not used to being separated from the rest of the group, and you don't want to introduce any stressful situation to them. So if they don't come in voluntarily, you have to wait. So it took a lot of training that they trusted us. And I can tell you, I first show you this how it looks like. Again, so there's the juice. We had to exchange one of the mesh to a plexiglass panel. This is chiffon. And there's the test. And I can tell you, so we spent 6 weeks testing every day, and we managed to finish 1.5 studies with 3 chimpanzees. So in terms of cost-benefit ratio, we repeated the same study in Leipzig. I had 1 week of testing, and I could test 16 individuals in 2 studies. So you always have to balance, basically, you have to calculate the effort and if it's really worth it. Problem is always sample size, right? I mean, in Leipzig, the 2 chimpanzees groups are, I think, 25 individuals you can work with. Not all of them want to participate in eye tracking. So you have to go to other places, but there you have to invest more time to get your data. Now the challenge is calibration. This is supposed to be a crystal clear plexiglass panel, which also costs 250 euros, but the apes really like to scratch their nails on it, and although we have a protective, also a panel added, still after a few trials you have to exchange it because you cannot measure gaze through the plexiglass panel anymore. And on the right you see Sveta. So she was the one we wanted to track. You see how this is going, because with infants, until they are 4 to 5 years, they don't, it's really difficult, you cannot separate them. So they're in the room. This is not very helpful when you want to test the gaze. Yeah, so, but it's nice because in such situations, of course, you cannot count this trial, but the offspring gets interested in this kind of task and also more relaxed in the setting. And so if you wait for up to 5 to 6 years, then you can also test this in the future. Maybe. Okay, so so far just to talk a little bit about setting. And now the question of if you want to study cognitive phenomena that are not, processes that are not directly visible, for example, skills related to theory of mind, then very often in humans you have very heavy verbal paradigms. And psychologists amongst you, or developmental psychologists particularly, are very familiar, I guess, with this example, classic test. There are tons of versions of it, but almost all of them are, as I said, relying heavily on language. Okay, and then what you do is you invite a child, and then you tell the child, so this is Sally. Sally has a basket, and on the other side is Anne, and Annie has a box. Sally has a marble, puts it in her basket. Sally leaves the room, but then Annie wants to tease Sally and puts the marble from the basket in a box. Now Sally comes back, and now the crucial question is, where does Sally look for the marble? And until the age of 4, maybe even 6 years, human children say in the box, because this is the last place where they have seen the object, right? And really, it's developmentally, it's really an important step to separate false perspective Annie has from your perspective that you have because you know what happened all the time. And how do you test this in apes? And one example for this is the so-called chimp chess task developed by Juliane Kaminski. There are different versions of it. You can play different games. Basically, you can test what apes have seen, not seen, what they like in terms of food preferences and stuff, to false belief tasks, so if they understand that others have false beliefs. So now I really have to focus because I think I would fail this task. Okay, you are interested in, so this is your subject. This is the competitor. So this is one problem. To motivate apes to participate in such studies, you have to use food, and very often you have to put this in a competitive situation. Unlike with humans, very often we have to cooperate to solve a certain task. You have 3 cups on a table, and there's a 4th one. This is the opt-out option, only accessible to your subject. And this table can be moved back and forth. You have 1 piece of food, and you hide, so basically when you look at this from the bird's-eye view, you have 1 piece of food, you hide it in full view of both individuals, okay? And then there's the opt-out option is not, so on the table is a very high quality food, both like. The opt-out option is a lower, still nice food, but not the same quality as the food on the table. Then there are different versions, but what you can do is then you block the view of your competitor. So she doesn't see what's happening, and then you move the food from this position to this position, and she can see it, right? And then she gets to choose. And the thing is, because she saw the food on this position here last, on this position, she will search for the food. And if she now knows that she doesn't have the knowledge that the food have moved, she went for this cup, and when now it's her choice, she will go for this one. Okay? Of course, you have to have different conditions. You have also to control alternative explanations. So basically, usually this test is studied in a 2x2 design. So either the reward is shifted, yes or no, and the competitor can see it, yes or no. The only option where your subject can get food is the option I've showed here. And this is a problem because you have to keep the apes motivated to participate. Because if they realize very quickly that they don't get the high quality food but have to go for the opt-out option, they lose interest. So this is a problem. So what we've learned from these studies so far is that yes, great apes understand the goals and the attention of others. They also know what others can see and the kind of knowledge they have or don't have, but they fail in this test. So the test human children pass at the age of 4 to 5, 6 years. Apes fail. Until recently, it's not so recently anymore. Chris Krupenia has conducted this eye-tracking study with a completely different paradigm, where he basically he investigated where the apes would predict, gazed at where basically the actor in a certain scene would reach to in the next step based on the different knowledge states. So I don't know how you feel about this, but this is really complex. Also human adults, so if you test human adults, there's quite a high proportion that doesn't pass this test, although this might be one problem. It could also be a memory problem, right? There are many different steps. You have to keep track of different actions. And as I said, non-human apes have a very short attention span. And they simply might lose interest and not follow carefully. Yes, but I wanted to use this as an example to show you how tricky it can be. So you have to be really creative if you want to know what apes, if they can take the mental perspective of others. I would like to talk about anthropomorphism and if and how it plays a role in our field. So one definition is basically if you use this when you look at other species, you attribute intentionality, so directed behavior and mental states to either living or also non-living entities. So this is a very broad definition. And this is a very nice, if you're interested in this topic, these two authors here have summarized this as a review paper, and it's really nice to get an overview about how this is relevant also for behavioral biology and comparative psychology in particular. And then I attended a conference a couple of years ago, and you might know Frans de Waal, who unfortunately died 3 months ago. A fantastic, so he can give fantastic presentations. His research is a little bit more debated in the scientific community, but he gave a talk and then he said, I'm not sure, when you're a biologist, you might be trained in a sense of, I know this is something I told you, Leah and Clara, like when you go and observe, you have to be neutral and you have to be distant, and you should not interpret and basically should not use human concepts to interpret other species' behavior. And he said, leading figure in the field, given that chimpanzees and other great apes are so closely related to humans, it is correct to assume that they feel and express emotions in a similar way like humans. So this is not a direct quote, this is a phrase from what he said. I thought, oh, this is interesting. I'm not sure if I would tell it to my students. And I would like to make a case why I think this can be helpful in some situations, but I would also like to show you an example where I think it's really a problem. So, I mean, again, this is nothing new. And if I would ask you what this person feels, I'm pretty sure you could basically link a certain emotion to each of these pictures. So we cannot help, right? Even if you're interacting, I see someone frowning, think, oh God, what did I just say? I see someone smiling. I immediately interpret certain emotional states from this person. Okay, is this a problem when we look at other species? Or what do you see? Is there any emotion you discover? There's no right and wrong, don't worry. Do you see a happy ape? Right. This one here? Yeah. Is this one happy?
Yeah, this one is excited.
This one here?
Happy, excited, I don't know.
And this one here? The rhesus macaque? Also happy?
Disgust.
Disgust. Ah, interesting. Ooh. Oh. Yeah, and you see, right? It's really easy to say. I think maybe the little one here is surprised. He might be laughing. So these were some responses we got. It's really difficult to not assign certain emotions to these pictures. What is the problem? I know this is a very scientific approach, but you have to trust me. If you would look at the facial configurations, this guy here, would you all agree that I mean, I don't know if he's happy, but it's a positive context. Yeah? I know we also have this fear grin, but let's say he's a happy guy. If you look at the facial configuration, he almost moves, so the little bonobo here moves almost the identical parts of his or her face. Problem is, in apes, this is an expression of when they are uncertain, for example, when they encounter higher ranking individual, and it might be even fear. So they show this when they are scared, this is their fear face. So basically, and this face here is the humans automatically link it to a smiling, happy ape. And the interesting thing is, evolutionary, they have the same descent. So they basically have evolved from the same facial movement. So as I said, the same muscles are moved. The problem is that across the different species, the use of this face varies very much depending on the social system they live in. So they have a very strict hierarchy. So the rhesus macaque uses this as a signal of subordinates to when they signal towards a higher ranking individual. Chimpanzees, as I said, situations and uncertainty, we use it in positive, relaxed context, but we also have this, right? When we have this fear grin, we also have this. But in general, it's used in a positive context. Okay, so we might attribute emotions incorrectly. And the Bridget Waller, now she's in Nottingham, she has led this initiative and developed different facial action coding systems. So based on Ekman's coding system for different species, you can see we have now cat facts. I was always joking that this is a very small one, but now I've learned that of course you have to take care of the apes they don't move the ears so much, at least not to communicate. Cats do. And Katja, she's here. She's currently working in my lab and about to publish now we don't have a fax system for gorillas and bonobos yet, and they will be out very soon. And now she starts to work on a bunny fax, because this has, and this might sound funny, but it actually has a welfare aspect, because if you, for example, when you are working in shelters, you don't know how well these animals are integrated and how they feel. And that's why some of these fax systems are used to exactly measure this. For the apes, so far we have used this for different studies. I show you an example in a second. Okay, so the basic idea is, instead of talking about emotions, you basically completely separate facial movements from the underlying emotional state, and what you look at is action units in your face, which are the result of certain muscle movements. And then what you have, we did the very same for gibbons, for example. So we developed a facial action coding system for gibbons. We did not dissect any gibbon faces. We did. We didn't. We did dissect gibbon faces. We didn't kill any gibbon. This is how I have to say this correctly. So we used a specimen from a museum. And what has been previously done is that you insert electrodes in the face for humans. So Bridget Waller, when she did her PhD, she had to basically had to do this. So to see which parts of the face are moving, depending on where you put the electrode in. And she had her whole face tested on this. You can't do this with the apes, but we have the dissections, and then you look at what they do with their face and how they then use it in social interactions. What is the problem? First, before I come to the problem, what is the nice thing about this fact system is you have a standardized objective method, and you compare a range of different species without talking about emotion. So there's inter-rater reliability, and you compare different species in a very objective way. And instead of saying, this is a play phase, because here you already assign a function to it, right? You say they engage in play, so they must be happy. They scream, so it must be a negative context. And the same when you talk about human faces. So instead of linking a face to a specific function, you describe it in terms of action units. Okay, then you might think, okay, that's nice, but the problem is you end up, and you code this, and we talked about this morning, what if I would have a wish, then I would wish that there are automated methods to code gestures and facial expressions in very blurry video footage of different ape species. And I know there are attempts, particular for action units, for facial movements, but we are far from using this in nature settings. Anyway, you end up, when you code this, with these endless lists of combinations which don't tell you anything, right? So it's really dry. You really need to love your job to do this. And the next step, and this surprisingly, this has very rarely been done, I think, because most researchers then gave up when they had all the codes to then say, okay, how are they actually used? Are there combinations, and are they meaningful? So if they suddenly a new action unit is added, does it change how a facial expression is moved? How do they develop? We know nothing about individual variability in the different. Nobody has looked at this. Usually, the idea is that facial expressions are very genetically determined. They cannot be very much voluntarily controlled, at least in non-human species. And so nobody is interested in individual and developmental variability. Okay, so this is, and I don't have any answer to this. We have two publications here with the gibbons, but this is just a very tiny bit of information how they're actually used in social situations. So it's a long way to go. We have no studies comparing different species with the same system, although we claimed it's really cool to have such a system in place to be able to conduct comparative studies. Okay, so now one last example, I think, and talk about, okay, so far I've talked about facial expressions, emotions that you can see in the face. What about emotions that are not expressed bodily? How do you measure them? How do you get to this when you're studying a non-human species? And we tried to do this with empathy. Sorry, again, I know, Lea and Clara, you know this, and I already presented this as a problem back then, and I can tell you we still have no solution for this. But we looked at empathy and the very related concept sympathy. So there are different ways of defining it. Frans de Waal defined it in a way that you experience, so when you see someone, for example, suffering, and you are in the same emotional state, when you feel with someone, then we talk about empathy. But you can also feel for someone, so you don't have to be necessarily in the same emotional state, but you can still do something that the other person feels better, and then we talk about sympathy or midlight. How do you measure this? So the problem is, with apes, we don't get to, if they feel empathy, no way, so far we didn't find a way to measure this. Sympathy, we can look at if the probability of helping increases depending on if they saw harm occurring to their individual, to another conspecific or not. Okay, please, so these are a little bit drastic terms, and I know I have to be careful here. So I hope you can see, this is an orangutan. And the basic idea is we needed to somehow harm an ape while another ape is watching here. And now when you hear harm, I guess Krista will already like, what happened? We have to be very careful here. How can you harm an ape and still be within the ethical, ethically, within the ethical regulations? And what we did was, we used food, and I basically gave the food to the ape, but then pulled my arm back and ate it myself. And this was enough. I can tell you they didn't like it, and it also never happened to them, although in Leipzig I think they did any possible test you can imagine, but their food is usually not being eaten. And again, this is the setting. So the human experimenter stands in front of an ape. We eat for 30 seconds. I ate food. I made sure that the other one was watching. This was a so-called emotional condition, and I had a neutral condition where I did exactly the same thing, but I gave the food to the ape, and again also for 30 seconds. And I show you, and I hope you can see it. And maybe you can watch the ape, because it's really mean, isn't it? Thank you. So you might see, so he also starts to scratch, and now, and at the end, so you cannot hear it, but there's also a so-called kiss squeak. This is a sound what they do when they are, usually when you are an intruder in their territory. So, so this was an example of the emotional condition. Then we left the situation. Oh, sorry, I have to say this to put this in context. This is in a sanctuary in Indonesia. It's young orangutans. They are there because the mother, they got killed, they get rescued, and then they are being rehabilitated and released to the wild. This is not their normal cages. So basically for testing, the keepers brought them there into this area, and then they lived. So they, in general, they lived with other peers, usually in groups up to 20 individuals. So just to put this in context, this is not their normal cages. And the same is also true for this situation. This is Leipzig, Wolfgang Köhler Primate Research Center, different ape species, so this is chimpanzees. And now you see, this is after I have stolen food from them. I leave, but I give 3 sticks to be used as tools to the previous, to the individual observing the previous harm. And I place 6 pieces of banana out of reach, so she cannot get it. And then I leave. And the question is, all these observers, so the individuals in a neighboring room, are they more likely to help after they have seen that I have harmed their conspecific compared to situations when I did not eat the food? Okay, so now I show you what happens. The other one has, sorry, so we had no camera in there, but you might see. So there's now some gazing back and forth to the food. She leaves again. So I do some gestures, and then she gets a stick, which is too short because the other one broke it. So this was not us being mean, and I'm pretty sure the other one also didn't do this intentionally. They like to play with these sticks. And now you can also see a very characterizing thing for apes. Humans very easily go and ask for help. Apes first, they have a higher probability to first try it on their own, and they prefer to walk on their own rather than working with someone. But she goes back, she gets another stick, and then this time she gets the food. Okay, and I use the situation to show you, it's really tricky, so these emotional states we cannot observe, it's really difficult to get to it. And this is so that that they got the stick after the harm condition. This is the only example when this ever happened during the whole test in chimpanzees. Orangutans exchanged sticks more likely when help was needed, but independent of whether there was harm or not. The problem is there are many different reasons. So the only where there was a statistically significant difference was in the Borneo population, in the sanctuary orangutans. They helped more only after they have observed that someone was being harmed. But there are many problems. It's a very special population. They have been raised by humans. They have been very young apes. And one problem, so based on this study, we cannot include that apes' helping behavior is not, or that they don't help because they don't feel empathy. It might be simply that our paradigm was not good enough. And back to the ethical question, there are limitations. You cannot do other things because you saw already they start to scratch and we don't want to stress them, right? So you have to be very careful and there are limitations what you can do. So there might be things we really want to know, but we won't because it's very tricky both methodologically but also ethically to get to this. Okay, so is this okay? I don't know, to be honest. I would be careful for the reasons I've just told you, but I will show you one example where we make use of this to study anthropomorphism in humans and what it basically, what it does to our perception. But first, one thing on a concept, so I'm not sure if this has been discussed also here in this context. If you hear about speciesism, it's usually, so it's about treating members of one species as morally more important than other species. And usually it means that humans are treated differently or humans separate themselves from other animals. But we also have an issue with this in comparative psychology. It's just that this topic is more and more discussed. And if this is actually a psychological effect or if it's just a matter of an issue of how you categorize your surroundings. But I would like to show you one example. I mentioned the self-medication and the kind of attention this received already. But I would like to come back to this test battery. Remember that I told you this was a test battery designed to argue that humans outperform apes, at least in the social domain. And it was published in Science. I did a rough calculation. It has almost 2,000 citations so far. It's cited 116 times a year. That might not sound very much, but we are a very small community. So comparative psychology is a small field. Then, a couple of years later, someone did the very same battery with old-world monkeys. They did not perform as humans did, but their performance was the same as those of great apes. It was published in +1, 12 citations per year. Lemurs. Have you ever heard of lemurs? These fantastic species in Madagascar, which are really cool because unlike great apes, we have, as I told you, sample size is a problem. We have 4 species of great apes. Each of them has a different social system. Each of them has a different feeding psychology. So statistically, you cannot do very much with this. Lemurs are amazing because you have very many different genera and they realize different social systems. So we can really test certain predictions. Anyway, and they're usually, even Claudia Fichte, so she's, lemurs are her species, she calls them my little no-brainers. But in the primate cognition test battery, they performed, not in all the tests, but in many of these different, I showed you the different subtests, they performed as great apes. It was published after, they fought for years in, this is a very nice journal, but it received much less attention than the research with great apes. Coming back to the point I made at the beginning, if you want to understand what makes us human, and we only focus on the great apes, and think we have a very limited picture of actually when we are not extending this to other, not only primate species, but also to other animals. And again, so I think this is something we might have to pay more attention in the coming years if the knowledge we have is actually representative for non-human primates as such, and it's clearly not. Okay, and last two slides. I like this study very much, and I cannot even present you. So data just came in we had a pilot. Now we collected a larger data set. I want to show you how you can also use humans' tendency to anthropomorphize other species. Completely different topic. We are interested in children's attitudes towards other animals, and we study how this changes during development. And we have data now from 18 different countries. We interviewed kids, a range of different questions, animals they like and dislike, if they eat animals, which animals, and so on. And we wanted to know, so for example, the first question in the interview, the animals they like, it was usually mammals. In Germany, it was animals that do not live here, elephants, tigers, whales. And if they talked about insects, it was mostly when they talked about things they find animal species they find disgusting or scary. So we thought, where does this bias come from? And we wanted to test if what influences if they perceive an animal as similar to humans or not. The problem is, for example, if you take a dog, so when you take different species and you take a dog, the experiences kids have with dogs vary drastically, right? So some have them as pets, some got bitten by a dog before, some have never seen a dog, and so on and so on. There was no way of controlling knowledge for each of the different species. So we created fantasy animals. So this is with an artist in Zurich, and this was actually a project by a student. So she was from the 10th grade. And we used then these fantasy animals. We had them always, we presented them in pairs. We came up with different stories, very short stories, and one story was more human-like, and the other story was more less human-like. And we had different versions, so social life, how they live, what they eat, and always two scenarios, and we basically paired all the different animals. They were paired with the different scenarios, and then we basically presented them as pairs of two, and told the two different stories. And then in the next step, we gave the kids 2 pieces of food and said, who would you give more food? As a measure of who do you like more? And basically, regardless of if you look at the different animals, then they also had certain preferences for some. So the furry animals are always a little bit preferred. But in general, children give more food to animals which are apparently more similar to human. And it was enough. Again, each animal was presented with each story. But just to pretend they are a little bit more like humans was enough. But the kids showed more pro-social tendencies towards these seemingly more human-like species. And this is, now we are playing a little bit around with this, not only with similarity, but also familiarity and usefulness. But we were really excited because we wanted to know if this method as such works. And yes, it did. Okay, so I hope I could show you that a comparative approach to human cognition is not only helpful to show what's uniquely human or uniquely chimpanzee, but I think it's also as exciting in this context to look at what is unique for one specific species of fish. I think depending on the kind of socio-ecological challenges they need to solve, they show very different cognitive skills. I didn't talk too much about this, but I talked about challenges. But the nice thing is also, because we have to always find new solutions for when we work with the non-human primates, sometimes this goes back, again, we talked about it this morning, right? The humans, we take for granted how things work because we understand our species, we think. I think this is wrong. And now we have many, many more non-verbal paradigms, for example, to study theory of mind in children. Because cross-cultural research has shown that, for example, in Papillon, kids only understand false belief when they are 9 years old. And the conclusion was they are delayed in their development. The fact is, the test was not translated in the appropriate way because it's heavily relied on language. And now in cross-cultural psychology, we have a whole new movement to take these methodological challenges and to also improve tests used for humans. Also not only to adjust them to study non-human. And as I told you, I have no real answer to this. I would suggest to be really careful. The anthropomorphism can be helpful in some situations, but I think as researchers, we always have to be aware of the problem that we cannot separate from how we see the human world. And if we just apply this without any questions to other species, you might come to the wrong conclusion.